calculus. Second half, 41. Find the second derivative of y cubed plus y equals 2 cosine x. We'll take the derivative. It'll give us 3y squared dy dx plus dy dx equals negative 2 sine of x by formula. And so this is dy dx. Not equals 3y squared plus 1 negative 2 sine of x. Divide it out. Dy dx. Our first derivative equals negative 2 sine x all over 3y squared over 1. Now our second derivative is going to be the derivative of this, for which we'll use the quotient rule. Probably need a little bit more space. So the bottom will be 3y squared plus 1 quantity squared. So we have bottom to top, so that'd be 3y squared plus 1 times the derivative of negative 2 sine x, which would just be negative 2 cosine of x. The bottom to top, top to bottom, will be negative 2 sine of x. And the derivative of 3y squared plus 1 is going to be 6y dy dx. So all we need to do is put in for this dy dx this here. Looks a little painful, but we'll do it. Probably need a little more room though. Let's split this off. It's easier to see. So we have d squared y dx squared. So this will go positive. So this is still 3y squared plus 1 squared on the bottom. I'm going to put this one first and this one second. This one doesn't change, so we'll go ahead and do minus 2 cosine of x times 3y squared plus 1. That just stays over there. This will go positive. The dy dx is going to be this here. So we'll have 2 times 6 is 12 y sine of x. And then the dy dx is out there. So this will be times negative 2 sine x all over 3y squared plus 1. All that's in parentheses. Maybe we can leave the compound fraction. Well, maybe not. We'll see what we need to do. So we'll put these up top. So it'll be negative 2. Sorry, this goes up top. So negative 24 y sine squared of x all over 3y squared plus 1 and minus 2 cosine x times 3y squared plus 1 all over 3y squared plus 1 squared. We can turn this into two fractions a lot easier. That'll be our final answer. Keep the top here, so it'll be negative 24 y. This is second derivative, of course. Negative 24 y sine squared of x over. So there's 1 down the bottom and 2 more down the bottom. So that's going to be 3y squared plus 1 to the negative 3. And then one of these can cancel. We'll just wind up with minus 2 cosine x over 3y squared plus 1. Oh, of course, it's positive 3. That's just silly. I think that'll do just fine. That's 41. see what was that. Was it 41? Onwards 42. Yes, that's cube root of x, cube root of y. All right. So take the derivatives. That'd be 1/3 x and negative 2/3 plus 1/3 y to the negative 2/3 dy dx equals 0. And then we go ahead and divide out. Well, we'll subtract and we divide out. Of course, the thirds are canceled. Well, okay, we do all the steps. 1/3 y to the negative 2/3 dy dx equals negative 1/3 x and negative 2/3. We divide both sides. We get a longer piece of chalk. That'll wear me down to nub. Equals something negative 1/3 x and negative 2/3 over 1/3 y to the negative 2/3. Now, thirds will clearly cancel. And these two can switch places because the negative exponent up top means we bring it down to the bottom. Negative exponent at the bottom means we bring it up top. It's going to be negative y to the 2/3 over x to the 2/3. And since I will have to take the second derivative of this, we might as well leave this all as 1. Let's not do quotient rule. Let's do product rule. So how about negative x to the negative 2/3 y to the 2/3. This is our first answer. We could have stopped there, but do this, we can do our second derivative. So now our second derivative, d squared of y over dx. The first times the derivative of the second. Derivative of the second is going to be 2/3 y to the negative 1/3 dy dx plus the second times the derivative of the first all right, and we're going to need how about this right up in here. I will rewrite this all right, we need to multiply all that through. So we'll wind up with, so this is a negative in here. It's all multiplied together, so we don't have to worry about adding distribution. Just put it all together. So two negatives makes a positive. X to the negative 2/3 and x to the negative 2/3 is x to the negative 4/3. Y to the 2/3 and y to the negative 1/3 makes y to the 1/3. Negative 4/3. Alright, so that takes care of that and that. And then these two, that's just, oh, I forgot about the 2/3 up there. Let's try that again. 2/3, the two x's, two y's, we're good to go. And then this in here says plus 2/3 x to the negative 1/3 y to the 2/3. And as we started with everything in thirds, I don't see any reason to muck with that any. We could pull out an x at best. Yeah, we could factor out a few things, but it wouldn't help much. But there's our solution there. This is the second derivative. That was 42. Alright, we need to find all derivatives of the function. So this function here is that y equals x to the 4th over 2 minus 3 halves x squared minus x. And so all the derivatives, I mean, there's only going to be 4 or 5 of them, because this is going to go away first and this will go away next. Let's just start on down the line and you'll see. Because we would have 2 or 3 of these, dy dx, and then d squared y over dx squared, and then d cubed y. Let's do the y prime notation. Skip the Leibniz notation for the time being. Alright, so this is just 1 half. 4 times 1 half is 2. X cubed. 2 times negative 3 halves is negative 3. X to the first minus 1. So that's one derivative found. Second derivative we'll find is going to be 6x squared minus 3. Third derivative will be 12x. Fourth derivative will be 12. And the fifth derivative, not much of a v, is it? Well, 0. And then all the further derivatives after the fifth derivative will be 0. So just repeated differentiation, which in a polynomial setting is pretty easy. And by easy, I mean it takes less than one shot word, which is always nice. 44. Same thing, all the derivatives of x to the fifth over 120. Oh, that's nice they set that up, because 5 factorial is 120. Alright, so first derivative is going to be 1/120th of x to the fifth. So 5 times, or 120 divided by 5. Well, we'll just do it out. 5 over 120, x to the fourth, which is the same as 1 over 24, x to the fourth. So our second derivative, 4 and 24 can cancel. It will be 4, I'll do it. 4 over 24, x to the third, which is the same as 1/6. Third derivative, 3/6. Fourth derivative, 2 times 1/2 is 1. Fifth derivative, sixth derivative. And all subsequent derivatives are also 0.